Okay, in this video I'm going to talk about rationalization of denominators primarily with radicals. We're going to start off with cube root because with square roots there's really not a whole lot to it. If you have, say, 1 over square root of 2 and you want to get rid of the radical downstairs, and all rationalization really is multiplication by 1 in a clever fashion. Matter of fact, a lot of math is really nothing more than multiplication by 1 in a clever fashion. But rationalization basically means you're trying to make the ugly stuff go away. With radicals, you're trying to make the radical symbol go away. In this first example, we have the cube root of 3x to the 4th over 2z squared, and it's all under the same cube root. Now, I suggest simplifying inside parentheses as much as you can whenever possible. And if you look at it, the only thing that you can really do here is the cube root of x to the 4th. 4 is bigger than 3. We can simplify that. So, this turns into x times the cube root of 3x on top. On bottom, we have the cube root of 2z squared. Now, to rationalize this, what I need to do is I need to multiply by 1 in a clever fashion. I need to make the radical part go away. I want to make this cube root go away. To make this cube root go away, I need to bring all the exponents in here up to 3 because that'll make the cube root go away. So, I'm going to multiply by 1. I want to multiply by a cube root. Now, the exponent on this 2 is 1. So, 2 plus 1 gives me 3. So, I'm going to multiply by 2 to the second power because 2 squared times 2 gives me 2 cubed. The exponent on the z is 2, so I'm going to multiply by z to the first because 2 plus 1 gives me 3. And what I do to the bottom, I have to do to the top, so I'll multiply this by the cube root. Now 2 squared is 4, and then 4z. Keep in mind that this whole thing right here, the cube root of 4z over the cube root of 2 squared, which is 4 times z, is really just 1. All we're really doing here is we're multiplying by 1. Now when I do that multiplication, I've got a nice little shortcut on the bottom because I have a cube root, and the whole purpose of doing this is to make the radical go away. So the bottom turns into 2z. Now on top, the x on the outside, I'm going to leave it on the outside, so it's still x. And because these are both cube roots, we can get by with just multiplying the bases together. 4 times 3, or 3 times 4, is 12, and then I have xz. Now, double check that radical. Make sure that whatever's under the radical is as simple as it can be. 12, if you think about it, the biggest exponent you have in the prime factorization of 12. Prime factorization of 12 is 4 times 3, or 2 times 2, or 2 squared times 3. All the exponents are smaller than 3, so that radical is as simple as we can make it. Also, the exponents on x and z are both less than 3, so that is as simple as we can make it. The second example, they wrote it a little bit differently. They wrote this as the cube root of 32 over the cube root of 12. One of the properties of radicals says we can think of this as the cube root of 32 over 12. And I'm a big fan of simplifying inside parentheses before you go on. 32 and 12 have a common factor. We can reduce them both by 4. So I can write this as the cube root. 32 divided by 4 is 8. 12 divided by 4 is 3. And if you think about it, the cube root of 8 is really pretty simple. But we can use that property of radicals again. Say this is the same thing as cube root of 8 over the cube root of 3. And now, well, the cube root of 8 is simply 2 because 8 is 2 to the third power. So this reduces down to 2 times the cube root of 3. And now for the actual rationalization, what we need to do is get rid of this radical downstairs. So we want to multiply by 1 in a clever fashion again. So this time we're going to multiply by the cube root. My base is 3. The exponent on this 3 is 1 under the radical. So I need to multiply with an exponent of 2 because 2 plus 1 gives me 3. Get your exponent up to your index. That's what you're doing. Now, keep in mind, you're really multiplying by 1. So you're going to multiply 3 squared is 9. And this turns into 2 times the cube root of 9 divided by 3. It's not a bad idea to take and look and make sure you can't reduce your final answer. In both these cases we couldn't. Okay? Now for the third example I have for you, we have the square root of y plus the square root of x divided by the square root of y minus the square root of x. To handle this one, we need to remember a simple factoring fact. If you remember, a squared minus b squared factors into a minus b times a plus b. And that's important because what makes a square root go away? A perfect square. So, when you look at this, you're trying to rationalize the denominator, you're trying to rationalize the bottom. You want to make the radicals downstairs go away. You want to make them disappear. We do that by multiplying by 1. Now, so when I look at this, I'm thinking of it as half of a minus b, a plus b, or a squared minus b squared. And what I need to multiply this whole mess by, or this whole problem by, is the other half of this. This is the a minus b, so I need to multiply by a plus b. And what I do to the bottom, I got to do to the top. And once again, notice that we're really just multiplying by 1 in a clever fashion. Now on the bottom, you have a neat little shortcut to simplify that. Because remember, the whole purpose is to make the radicals go away. This is a minus b times a plus b. When you take a minus b times a plus b, you get a squared minus b squared. A is the square root of y. The square root of y squared is simply y. B, and it's going to be minus, b is the square root of x. Well, when I square the square root of x, the square root goes away, so the bottom is simply y minus x. That's the whole point behind this problem. On top, you have to full it out. Remember, full, first, outer, inner, last. The square root of y times the square root of y is the square root of y squared, or y. Then you're going to have plus the square root of y times the square root of x, the outer ones. And because they're both under the radical, you can write that as the square root of yx. Then the inner ones, the square root of x times the square root of y, well, that's going to be the square root of xy or yx, or you should write them in, doesn't really matter. Then the square root of x times the square root of x, well, once again, the square root just goes away, so we get plus x. Now, looking at the top, you can combine these two middle terms, not unusual at all with full. The square root of yx plus the square root of yx, there's a 1 here, a 1 here, 1 plus 1 is 2. So our final answer here is going to be y plus 2 times the square root of yx plus x, and this is divided by y minus x. Okay? Alright. So, that is rationalization of denominators. Alright? Good luck. Go do some math.